Find all solutions of 2 cosine squared of theta minus 1 equals 0. First, we isolate theta by isolating cosine of theta. 2 cosine squared of theta minus 1 equals 0 is equivalent to 2 cosine squared of theta equals 1, where we add 1 to both sides of the equation. This is also equivalent to cosine squared of theta equals 1/2, where we divide 2 both sides of the equation. We now have cosine squared of theta equals 1/2. To read the information from the unit circle, we would need to have cosine of theta, so we square both sides of the equation to get cosine of theta equals plus or minus the square root of 1/2. Don't forget the plus or minus. We rationalize the denominator to get cosine of theta equals plus or minus the square root of 1 over the square root of 2, which is the same as plus or minus root 2 over 2. This will give a 2 equation. Cosine of theta equals positive root 2 over 2, and cosine of theta equals negative root 2 over 2. It makes a whole lot different whether we include the negative or not. We then read the information from the unit circle. Cosine of theta equals root 2 over 2. Cosine is defined on the unit circle as the x-coordinate root 2 over 2. And in the first quadrant, x is root 2 over 2 only when theta is pi over 4. In the fourth quadrant, x is also positive root 2 over 2, and the angle that determines the terminal point is 7 pi over 4. From cosine of theta equals negative root 2 over 2, which is now in the second and the third quadrant, the angle that determines the x-coordinate negative root 2 over 2 in the second quadrant is 3 pi over 4, and the angle in the third quadrant is 5 pi over 4. So we obtain 4 initial or 4 principal solutions from 0 to 2 pi. If we go around another cycles or another rotation, we will obtain another 4 solutions. And also, if we go clockwise, we would obtain 4 negative solutions. There are infinitely many solutions here. It is true that we can list our solution by taking each of these and add 2k pi, because the period of cosine is 2 pi. Thus, we can take 3 pi over 4 plus 2k pi. Theta equals 5 pi over 4 plus 2k pi. Theta equals 7 pi over 4 plus 2k pi. But this is in poor taste, and it is simply incorrect notation. Observe that pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, they are 2 pi over 4 units apart. What this means is that if we take pi over 4 and add 2 pi over 4, we will end up with 3 pi over 4. If we take 3 pi over 4 and add another 2 pi over 4, we will get 5 pi over 4. If we take 5 pi over 4 and add another 2 pi over 4, we will get 7 pi over 4. What this means is that we simply add 2 pi over 4 or subtract 2 pi over 4 to obtain the next solution from the initial solution pi over 4. In an expression that means theta equals pi over 4 plus k 2 pi over 4. So the general solution is pi plus 2k pi the entire expression over 4. This can also be expressed as pi over 4 plus k pi over 2. Usually we express this in this notation to emphasize that the initial angle or solution is pi over 4, and after that we simply add pi over 2 or 2 pi over 4 each time to get to the next solution, or subtract. This k is an integer. It can be positive or negative.